Okay, so we're going to take a look now at the preparation of ethene gas, and I want you to remember that ethene is the first member of the alkene homologous series. There is no such thing as methene, and I hope you can understand why. Meth means one carbon, but in order to have a double bond with a second carbon, I need a minimum of two. So therefore there's no such thing as methene, but there is such a thing as ethene. So ethene is the first member of the homologous series that we call the alkenes. And relatively easy experiment in the lab. Just one thing we've got to be careful of, which I'll talk about in a few moments, but it's a relatively straightforward process by which we simply remove a water molecule from an alcohol molecule and we form the alkene. Okay, so ethene is prepared by the dehydration of ethanol by Al2O3. Now, a couple of things about that. First of all, dehydration. If you're described as being dehydrated, it means that you don't have enough water. Dehydration in chemistry is a process by which we remove water from a substance. And the way in which we do that here is by aluminium oxide. Aluminium oxide. Okay, and aluminium oxide, as you can see, is a catalyst, which means it remains exactly the same afterwards as it was before. Might look a little darker in colour, but it is still aluminium oxide, which could be used again if we were to do this procedure over and over and over again. So just to get the words out of the way, ethene is prepared by the dehydration or the removal of a water molecule from an alcohol that we call ethanol by a catalyst called aluminium oxide. Okay, now what does the actual apparatus look like? The apparatus that we use happens to be a horizontal boiling tube which is clamped. Now, we don't ever draw clamps in these things, but that's the diagram there. So a horizontal boiling tube which is clamped. We stuff a bit of glass wool down the bottom, and I'm not too sure if you've ever seen glass wool before, but glass wool looks for all intents and purposes like candy floss, except when we touch it, it's very brittle. It's quite hard. It's easy to bend, but should it get under your skin, because it's glass, it'll stick there, and it's actually quite uncomfortable when it gets under your skin. So we have to handle this thing with gloves, but I'll show it to you when we go back to the lab. It's like candy floss, so we cut off a piece and we basically stick it down into the bottom of this boiling tube here, and we put it into a little ball, and then we pour on our alcohol. So I hope you can see the reason for that. The glass wool will actually absorb the alcohol, and it will hold it here when the boiling tube is horizontal, so that it doesn't run into the aluminium oxide and destroy the experiment. Then we put in a little spoonful of aluminium oxide, which is a white powder, by the way, in case you're wondering, a white powder, and a little teaspoon here, and then, or teaspoon I should say, a spatula full, and then we heat directly from the Bunsen burner. Now, that has two effects. First of all, it heats the catalyst, so that it can be much more efficient, but secondly, it causes the alcohol, which has a low boiling point, to start to turn into a vapor. And as it turns into a vapor, it runs over the hot catalyst and it loses its water. The H2O is removed. So therefore, what is ethanol here, over the hot catalyst of aluminium oxide, loses its water, then it runs down this tube here like that, and then notice that it's collected in an inverted boiling tube, and it bubbles through the water and it's collected up here. Now, a few words about what's going on over here. First of all, we notice that the gas bubbles perfectly through the water. And that's extremely important in chemistry, because if the gas bubbles through water and can be collected in the upside down boiling tube, that means that the gas doesn't dissolve in water. Because if it did dissolve in water, the gas would simply disappear. We wouldn't be able to collect it. So that stream of bubbles there tells me that ethene does not dissolve in water, which is very handy. Okay, that's the first thing. Then the second thing is, as it's collected up here, this boiling tube, which was originally filled with water, we normally fill it with water, put our thumb underneath it, put our hand into the water, take our thumb away, the whole thing is full of water. But as the ethene gas collects up here, it pushes the water downwards, downwards, downwards until this boiling tube is full. And then we normally put a cork in and we keep it. Normally 3 of these we produce when we're doing this in the lab. That procedure actually has a name, believe it or not. It's called the downward displacement of water. Okay, so it's the downward displacement of water. So the two things I want you to remember over here are that because the gas can bubble through the water and be collected, the gas is not soluble in water. And secondly, as the gas collects at the top and pushes the water downwards, that's what we call a procedure called downward displacement of water. So they're the two things I want you to remember. Now, there's one extremely important safety concern here, and maybe you might be able to see it. If I was to remove the heat straight away, this would start to cool down. And as this starts to cool down, the gas inside starts to contract. Remember that from junior cert science? When things get cold, they get smaller. So the gas in here would start to contract quite rapidly, which means now that we get a suction effect, pulling the water up through this tube very, very quickly and into the horizontal boiling tube. Cold water, extremely hot glass, what's going to happen? Yeah, the glass is going to shatter. So we've got to be very, very careful, and this is a safety concern that we always have to remember. Before we remove the heat, we take the tube away from the water. So it's always tube out of water before you remove the heat. So tube out of water before remove heat. That's extremely important. And once you've done that then, and the tube is taken out of the water, you may then remove your heat and let the whole apparatus calm down and cool down. So just very quickly again, over here what's happening? We've got glass wool with our ethanol, so that holds the ethanol in place. We've got a spatula full of aluminium oxide here. Then we have a delivery tube, which is going to deliver my ethene gas into my inverted boiling tube here, which is already full of water. We bring the Bunsen burner directly underneath the catalyst, which will help it to act more efficiently. Also the heat, it will vaporize, or it will turn the alcohol into a gas. The gas will begin to move over the hot catalyst, and as it does, it will lose water, and as it loses water, it will become ethene. So it's ethene that comes out here. And I'll show you the little chemical in a moment, the molecules. So the ethene comes down then, passes through the water. What does that mean? Well, if it passes through water, it doesn't dissolve in water. It's not soluble. And then it's collected up here by downward displacement of water. The only safety concern we have to remember is that before we remove the heat, and that's extremely important, before we remove the heat, we take the tube out of the water, then we can remove the heat and allow the whole thing to cool down. So what does dehydration actually look like? Well, it looks like this. There's your alcohol molecule. Okay. Now, as we're going to find out when we study the alcohols next year, alcohols are any carbon-based spine that has an OH group. See that? And that, yes, okay, that's what makes you drunk. Not that you know anything about it at the moment, but that is responsible for making people drunk. Too much of this thing is bad for you. But anyway, that's your OH group. The alcohol, when it's vaporized, passes over the hot aluminium oxide, so I have it in red. As it passes over the hot aluminium oxide, what happens? It loses water. Now look, it loses H2O, so it loses that and it loses this. And what happens is one little electron there and one little electron there remain behind. So they join up together and they form a new bond in here between the two carbons to give you a molecule which is C2H4. And C2H4 is the first member of the alkene homologous series, which we call ethene. Okay, so that's everything you need to know about that particular process. But I think it's nice to see the molecules. You can see it. C2H1, 2, 3, 4, 5, H5OH. But we always name the OH on its own. Passed over the hot catalyst, loses water, so it loses these two together. They're chopped off. The two electrons remaining behind join together and form a double bond in between the two carbons, giving you that molecule which we call ethene, C2H4. Okay, so what do we do with ethene? Normally we collect 3 of these particular test tubes here. So just let me take off the writing from there. This one. Okay, so just one little box down here. Ethene gas collected by downward displacement of water, we know that. And this also shows it's not soluble. So because it pushes the water down and because it moves up through the water, those two things are extremely important. Collected by downward displacement, and because it moves up, it doesn't dissolve in water. So normally, as I said, we take 3 of these particular test tubes. Oh yeah, you can see that video yourselves later on. You can have a look at it in the slides. I'll send them to you and you can just press that link there and the show will start. Okay, so let's take a look at what we would do with the 3 test tubes. First of all, we would actually look at the physical properties. Physical properties means, does it have a colour, does it have a smell, is it heavy, is it light, etc. So what we notice is that it's colourless, and if we were to waft it under our nose, not shove it up our nostrils, but just waft it under our nose, we'd notice a kind of a gently sweet smell. Now, I want to talk about that. Ethene and sweet smells. Have you ever left fruit in a fruit basket on your table? And you walk by it after 2 or 3 days and you get that lovely smell of fruit. That lovely sweet smell is actually the ethene that's being produced by the fruit. Because ethene, I'll write it in here, ethene is the gas responsible for ripening fruit. So that's why it has a lovely sweet smell. So when you're walking by the apples and the bananas and the oranges that are on the table, they are all the time creating ethene so that they can ripen into a fruit that becomes very edible and very tasty. Secondly, in the second test tube, what we normally do is we take off the lid, we stick in a match, and we watch what happens. And ethene itself, again, as you'll see from the videos that are on the slides, it burns with a lovely luminous flame. So it gives a nice yellow flame. It doesn't give very much soot at all. It burns well, gives a nice flame, and that's what we call luminous. However, when you burn any hydrocarbon in oxygen, you get 2 things: carbon dioxide and water. Okay, so it burns with a lovely kind of a luminous flame. There it is. There's your C2H4. There's your molecule, C2H4. There's your oxygen, which gives you 2 carbon dioxides and 2 H2O. So you can balance that equation yourselves, as you should be able to. Okay. Thirdly then, it decolorizes bromine water, but it also decolorizes acidified potassium permanganate. Again, you'll see this on the video. Bromine water is a pale yellow. And when we put ethene through bromine water, the double bond opens up, it bonds to the bromine and destroys the yellow colour. Same thing happens down here. When we put ethene through acidified potassium permanganate, now don't worry about too much about the word just yet, but potassium permanganate, which is a deep purple colour, the double bond opens up, it bonds to the KMnO4 and it loses its purple colour. So therefore, there are 4 things we've got to remember about ethene. Number 1, it's a colourless gas with a sweet smell. Number 2, it burns well in oxygen, giving it carbon dioxide and water. Number 3, it decolorizes bromine water from yellow to colourless, and it decolorizes acidified KMnO4 from purple to colourless. And the reason KMnO4 is acidified is because that makes it very, very active. If you didn't have an acid in with the KMnO4, it would be quite sluggish. So acidified KMnO4 becomes very active KMnO4, which basically bonds with the ethene molecule, opens up the double bond, and then changes from purple to colourless.